table, and I just heard it. So it's a little bit pain for me to put the blackboard. So you will see me sometimes I will use my left arm to erase the blackboard. Not very smooth. Okay, let's go back to something. Let me explain in more detail. So, if this is the utility, which is actually the Lagrange, okay? Because the constraint in the Lagrange function would be met or would be satisfied at the optimal solution. And this would be Q1, Q2, the plane of Q1 and Q2. Of course, because I just gave you something like 5 Q1 plus 2 Q2 equals $300, right? So you may choose your consumption, say 60, 0, right? You may do this. And also you may do something like 0, 150. Or you may do something like 10, so if it is 10 to 250, 125. Or 20, 100. Or 30, 75. Is that right? You have numerous consumption bundles you may choose. And we know the optimal one is 2490, right? This is the optimal one. So you may choose on the plan either, say, 2000 or 3075, or this would be 2490, right? So the optimal choice, which means on the plan of Q1 and Q2, once you choose 2490, you will reach the optimal level of utility, the highest utility, right? Because our objective is to what? To maximize our utility, right? This is what we want. So what is the level of the utility? U star or Lagrange star, it would be 24 to the power of 2 and 90 to the power of 3. Is that right? And we just define this as nu. So nu is a function after our replacement of the optimal solution back into Lagrange or back into the original problem. If you replace or if you decide to consume 2000, then the utility level you will have will be 20 square 100 qubit, right? This will be the utility level. And if you choose this bundle to consume, your utility level will be 30 square multiplied by 75 qubit, right? But they would not give us the highest utility level. This would be the highest because we have already solve using the first order conditions to find the optimal solution, and the optimal solution 2490 is something that can give us the highest level of utility. Is that clear? Okay. So nu is something we call it the optimal level of utility. All right, let's proceed to this slide. Now we want to talk about the expenditure minimization. Not this one. This one. So our issue is to minimize P1Q1 plus P2Q2, the total expenditure subject to a utility level constraint on U bar. Just like this. We have an indifference curve denoted by U bar. And we want to minimize the expenditure. Okay? And this depends on the slope. So if you give me another set of P1, P2, we may have another slope of the budget constraint, right? The budget line. So the solution may change. The solution may change. Okay? It depends on the slope. But the basic issue is to minimize the expenditure. Now, the same procedure, let's put down the Lagrangian function. And the first part would be the objective expenditure, total expenditure, plus the multiplier, and followed by U bar minus U of Q1, Q2. So this is the constraint we just put into the parentheses. How to interpret the multiplier now? Can you give it a interpretation? Remember, let's recall this. Lambda here is the marginal utility of an additional y, an extra income. The reason why it is the marginal utility is because our objective is utility. Okay? So we want to maximize our utility. So this is the marginal utility by an additional y. And now, the Lagrange here is the expenditure plus lambda U bar UQ1, Q2. U bar is a requirement. It is a requirement of the utility level. So we may interpret this problem as follows. Given the utility level we are required to achieve, what would be the minimized or the minimal expenditure? So how can we spend the least money to reach the utility level U bar, right? You give me a requirement U bar, and I will tell you how efficiently I can to spend money as less as possible. So the least money I expend to reach your requirement U bar is the solution. Okay? What about if the requirement is raised a little bit to U double bar? So now you will see U double bar is higher than U bar, right? So the requirement of the utility level is raised a little bit, and we may have another solution here, right? This would be the new solution. So given different requirements, our solution, our optimal solution will change, because now the requirements are different, right? Just like if you are given a different budget constraint, if you have a higher income, your best solution will change. Okay? Now, given the utility requirement, we want to minimize our expenditure. So how to interpret the multiplier here? The multiplier here would be, listen to me, pay attention, would be the marginal expenditure. This is the marginal utility, so it is the marginal expenditure caused by an extra requirement of the utility level. Is that clear? For example, if you ask me to reach utility level something like 200, the height of the utility level, 200. If you just raise up the requirements a little bit to 201. So you will see my expenditure, my optimal expenditure will be a little bit higher, right? It will be a little bit higher. I got to pay more to reach your further requirements. Is that clear? It is impossible that my expenditure under this requirement would be less than under this requirement, right? Because you just make the goal, the target, higher. So I want to reach a higher target. I got to spend more money. So my expenditure will be raised. Alright? Therefore, lambda represent the marginal expenditure we got to pay due to or because of this further requirement. Okay? So if you raise up your requirement by one unit of utility, so you raised U bar by one utility level, then lambda would be the marginal expenditure we got to pay. You raise up your target a little bit higher, I have to pay more. And lambda tries to capture the amounts we got to pay due to your further requirements. Is that clear? Okay? Once again, this lambda captures the marginal utility of an extra income. Because you have more money, you may reach a higher utility level, right? Now, this is the utility requirements. Once you raise up your requirements a little bit, I got to pay more. My expenditure will be higher. So this lambda captures the extra or the marginal expenditure caused by an extra increase of the utility requirements. Is that clear for you? Okay? Remember how to interpret this. Okay, now, given the Lagrange multiplier, we may, by the same procedure, we may have these three first order conditions. And the first one differentiates Lagrange by, with respect to lambda. So total, in the total equation, we have lambda here only. So the result of the differentiation will be u bar minus u of q1, q2. We set at 0. And this is exactly what the constraint, right? And the second first order condition with respect to q1. So now we have a q1 here, we have another q1 here. So the first q1, we have p1 left. And for the second q1, we have minus lambda. And partial u, partial q1, we have u1. Is that clear? Okay? And the second would be differentiate Lagrange with respect to q2. We have a q2 here, so we have p2 left. We have another q2 here, so we have a negative lambda and u2. Negative lambda and u2. Alright? Alright. And we may utilize the last two equations. We put this term to the right-hand side, and this term to the right-hand side, and divide these two equations. So we have p1 over p2, which would be like lambda will be cancelled, u1 over u2. And if we add a negative sign here, again it would be MRT equals MRS. So you will see MRT is the slope of the budget line. We wanted to spend less, so we want to try to minimize the expenditure. So the condition of the solution, of the optimal solution, would be the tangent condition. So the slope of the budget line equals the slope of the indifference curve. So once again, MRT equals MRS, just like that in the utility maximization. So we have this. And we want to interpret the first order condition here. Let me give you a comparison. By these two problems. U1 minus lambda P1. Remember this? This is in the utility maximization problem. We want to maximize our utility. And P1 minus lambda U1. This is the issue in the expenditure minimization. Okay? Here, how can we interpret this first order condition? We say, if we increase the consumption on good 1 by 1 unit, we may have the marginal benefit of U1 because 1 more Q1 gives us U1 more unit of utility, right? So this would be the marginal utility of Q1. It's the marginal benefit. However, if we buy 1 more unit of Q1, we got to pay P1. And which means our income will be cut by P1, right? 1 more unit of Q1 costs us P1. So our total income will be cut by P1. So this will be cut by P1. And per dollar, lambda means the utility of an extra Y, right? So lambda is the marginal utility per dollar. So now your income is cut by P1. So this would be the total utility you will be cut. Utility, right? The same unit, and you'll be cut. So this would be the marginal cost. This is the marginal benefit, the marginal cost of one more unit of Q1. So your optimal condition, when you are at equilibrium, at the optimal level, your consumption on good one would be like this. The marginal benefit equals the marginal cost. Is that clear? One more unit consumed of Q1. Now, how to interpret this? One more unit of good one cost us P1, right? So this would be the marginal expenditure. This would be the marginal expenditure. Because now, we want to minimize our expenditure, right? If you buy Q1, buy commodity 1, buy one more unit, you want to buy an additional Haagen-Dazs. So you got to pay the price of the Haagen-Dazs, right? So this is the cost you got to pay, which means your expenditure will be raised up. So this will be the marginal expenditure you have to pay if you want to consume Q1 one more unit. You got to pay P1, okay? I already tried very hard to repeatedly explain this. And, however, your additional consumption of Q1 will make you happier by U1 unit. So this will be the marginal utility you will have after you consume one more unit of Q1. Okay? So this is the benefit you have. And because the target is U bar, if you are here and you consume one more unit of Q1, you will have an additional utility increase by U1, which means the distance from where you are now to the target will be U1 less. You are closer to your target, to your destination. Is that clear? U bar is something, the target you want to make. So where you are, and this is how far we are from the target. After one more unit of Q1, after consuming one more unit of Q1, let me say, okay, this is the target and where I am. And I have another Haagen-Dazs. After eat the Haagen-Dazs, I feel happier, so my utility level is raised, right? I'm closer to my target, U bar. So how closer I can make it? It will be U1, the marginal utility of the consumption, right? So initially we are this bar, and after one more Haagen-Dazs, I'm happier by U1. So I'm closer to my target by U1, okay? So my pressure, because initially I got a pressure here, I have to reach U bar. So I try very hard to save my money. I don't want to spend that much. I want to save my money to make the expenditure less. But the requirements just like here, okay? And I feel some pressure because of the distance is still very far. But after consuming one more unit of Haagen-Dazs, I feel better, I feel happier, and the pressure will be cut by U1. Okay? The pressure will be cut by U1. And remember what? How we interpret this lambda is an extra expenditure by the requirement, right? Now, the requirement is released, or the pressure is relieved by this much. So this is per unit of further requirements. But the requirement is now relieved by this level, and per requirements, per unit of requirements, ask us to pay extra expenditure. But now it's a negative sign here, our pressure is relieved, so we do not need to spend that much. Our pressure, or on the expenditure, we can cut our expenditure by this unit. So it's the marginal benefit, or the marginal saving. We may save this amount of expenditure. Is that right? Okay, understand? The utility target, the distance, and the distance is measured by utility level. Okay? So if I'm a little bit far from one unit utility, far from the target, I will feel stressed. I got some more pressure to spend money, alright? And lambda would be the marginal expenditure I got to pay. Okay? So now, in the contrast, I consume one more unit so that I got some more utility, and the distance is cut by U1. And my pressure is relieved a little bit. So the pressure relieved can save my money to spend on the expenditure, is that right? I can pay less because my target is closer. Okay? So cut by this. So the unit would be dollar. The unit would be dollar. Its utility is dollar per utility. So it's dollar. Okay? So this equation is measured by dollar. This equation is measured by utility. See the difference? I hope you may respect yourself. I mean, I hope someday after your graduation, so you look back to the time you spent on, say, microeconomics, and so you will see, okay, after 4-year stay in NCU, I increase something, or I bring something with me so that I may become a better person. I may have more ability. I may have, or I may be mature, much more mature, and I like myself more, something like that. So I hope you may bring something with you. And one thing is that you may sharpen your thinking way. You may open your eyes to the world. Okay? Not the physical meaning open your eyes, but you may have a different sight on the nature of the world. You may see something. You may have some more better intuition than others without this kind of training. Okay? So since you are trained, I hope you can grasp this opportunity to sharpen your thinking. So this is something you may think or you may have. Once you understand the first order condition, you will see something more intuitively. So someday, when you are leading a team,